Hello everyone, welcome back to my YouTube channel. My name is Talhaftab and today we are going to learn about AVR. The AVR with the book we are reading is the AVR microcontroller and embedded systems using assembly and C. Anyone who wants a book, who wants to buy it, they can buy it from the Amazon. It's available on Amazon. I can put the link in the description. So today we are overviewing the examples from chapter number 7, that is AVR programming in C. So we'll be using Proteus software for simulating the source code we have. So let's go on to the Proteus. This is the Proteus we are using. This is just a simple. We have put the AAT Mega 2560 IC and we'll be simulating the source code here. So let's go on to the source code. Example 2, let's see. So let's take it from here, copy and paste in the Proteus, and then we'll see how does it works. So I've placed it here. Let's rebuild it, and it's compiled successfully. So let's run and I'll explain how it works. So as you can see, it's running, and what's happening in this is that we have made a simple program. It's the program starts with the library include avr io.h. That's the standard library for using the AVR or the ICs that we use, the AT Mega 2560. Then we have the end main, the standard procedure for writing the program in C or C++. Then we have declared unsigned char mylist. It's an array mylist that we have initialized. After that, we have char z. I've initialized as an integer. I've just initialized in char because it can have any value like in integers or alphabets. Then we are declaring ddr b is equal to 0xff. This means that we are declaring the port B as output. Then we have a for loop that in which z is equal to 0, z is less than 10, z plus plus. It means that z, the initial value of z is 0 and it will go up to 10. So like 0 to 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 iterations. Then we have while 1 and return 0. So this is how the first example works. Then, and this is the Proteus. If you can see the blinking lights, let's run it. And here the blinking light shows that the port B is on and it has the outputs we have. Let's go on to the example number 2. Let's see example 4 from this. So if we take this copy, Control C, and let's stop the simulation from here. Source code, Control A selector, Control V. So now, let me explain how this codes work, then we can simulate it or rebuild it. So same procedure, in hashtag include library int main. Then we have declared an array of binum that has like negative integers, 0 and positive integers. Then we have declared a char z. Then we have declared the port B as output again. Then we have a for loop in which the integer 0 or the char we have initialized the variable z goes from 0 to 8. Less than or equal to 8 means it will go up to 8, like 0, 1, 2, 3, 4, 5, 6, 7, 8. And z plus plus is the increment. Then the port B, the mynum and z, as the z changes from 0 to 8, the mynum will get update and show the output on port B. While one shows that it's continuous, it's going continuously and it will not stop. Let's rebuild it quickly. So it's taking a little time here, but hopefully it will be successful. Yes, it's compiled successfully. Now let's go to the schematic and let's run it. So here, as you can see, the port B is, the LEDs are on, the switches blue and red shows that it's working. Now let's move on to our next example. We can let's see, we can check example. Which should we check? Let's go for example number 11. They're all the same, they're just minor differences in them. So let's go to it. Same procedure. Control C, and the simulation is stopped. Control A to select all. Control V, paste here. The same procedure happening in here. Include library int main. Then we have the chart temp. The temp a variable is used for if we want to save anything temporary, and that is used next. So we store in a variable char. DDRC is equal to 0. DDRB is output, and DDRD. So the port C has a value of 0, and port B and port D are used as output here. While one means it is, the loop is going forever, like it's continuous. Until the system is running, it will be running continuously. So temp is equal to pin C. It means that any input that is coming from the pin C or the port B, the input, particularly when we use the ports, if we are using it for the input, we use the pin C, and if we are using it for the output, then we use the port B. Or for example, the port and pin, the difference I'm telling you about it. So pin C, then we have, if temp is less than 100, then port B is equal to temp, else port D is equal to temp. So if temp, the input from the pin C is stored in temp, and if we check if the temp is less than 100, then the output will be stored and showed on the port B, else it will be shown on temp port D. So then we return it, and let's run, and let's see, play. Oh, I'm so sorry, I haven't rebuilt it. So hopefully it will rebuild successfully. Okay, so we have some error. Let's see what error we have in it. Oh, we haven't closed it. I guess that was the error. Hopefully it will fix it. It's compiled successfully. And now if we run the schematic here, so yeah, it's running. The port B are all blue, and the port D is also blue. So it means that we have the port B and port D running. So let's move on to the next example here. We have searched for the 11. This one, let's work on, I guess we should move on to 12. Let's see what the 12 got for us. What I'm doing here, I'm just explaining the source code, the example codes that are available on in the AVR book, chapter 7. We are overviewing them. Okay. So if anyone have any problem and they cannot understand, do comment and I'll reply back to you and surely explain it to you. Or maybe if the comments are more, I can make another video about it. Surely. So let's rebuild it. So the same procedure, the DDRB is used as output C, also output D, also output. Then the B has been given the value of 0x35 and 0x0F, with the C 0x04 and or 0x068, then 0x54 X or 0x78, port B not 0x55, while 1 returns 0. So if we run the schematic here, so there you go, it's running, and you can see, if you stop it, you can see the source code. So it's just using the values here that it's been given, and it's processing that. Okay, let's see next example we have. Let's move on to example number 14. Let's see what it got. Example. So yeah, we are overviewing example number 14 here. Control C, Control A, Control V. Let's put the hashtag here because it's syntax, so you cannot mess up with that, else it will not run. So hashtag include and int main the same procedure ddrb as output ddrc. Look here, we are using the ddrc is equal to 0x00. It means it will be used as input. Something will be given to it and then it will process, and ddrd also as output while one continuous loop. Then if pin C and is not equal to 0, so the port B is equal to 0x55, else the port B is equal to 0xAA. It means that the input at pin C that is given, it will verify it with the number we have here, and if it's correct, it will send it to the port B as it will be sent to the port D. So let's compile it. Hopefully it will compile successfully. Because I see no error in it. Yes, it's compiled successfully. Now we can run the schematic. So here we have just basic configuration of 80 mega. So we don't see much. We are not giving any input at C, but we can see the output at B because it's just running continuously. So it's running. We can see that the source code is running. Yeah, we can be sure of that. Let's move on to the next example. That would be 17. Then we'll cover 25, 27, 30, and 34. So 17 it is now. Okay. Now let's the same procedure be Control C, Control A, Control V. Okay, I have missed hashtag include. Yes, okay. So the library again, the int main function, then the unsigned char, we have initialized a variable z in char. Then ddrb is given the value of 0 this time, and ddrd, the port D, is initialized at out as output port. So while one continuous loop, z is equal to pin B. So any input that comes from pin B will be stored in the z variable. Then z and 0ob 0000011, they are being AND. So if they have the same value, it will store it. Then we are using the switch here. The case 0 is port D is equal to 0. Then break if case 1 port D is equal to 1. Then case 2 and case 3. And this is how it works. So let's run it in the schematic. So I haven't, I guess, rebuilt it, but it's still working. I guess the previous one is working. Let's rebuild it quickly. It's being rebuilt. Compiled. Yes, it's compiled successfully. Now we can run it in the schematic. So yeah, it's running. The port D shows output here. So now we move on to the next example. That would be 25. Okay. So here it's defined as LED and sensor, and DDRB and equal to NOR 1. So here this is used to mask inputs or mask the values. So if my sensor has any value, it gives any value, I'm checking it if it's 1. So the not means that it shouldn't be equal to 1. If the values is 1, it won't be stored. So the ddrb and equal to not 1 less than sensor, then ddrc or equal to 1 less than LED. Then the while 1 if pin B and 1 less than sensor, then the port C will hide the value of LED, and then else if not, then the port C will and equal to not the 1 1, then it simply means that the port D has a sensor integrated to it, and the port C has an LED. So the sensor gives us input at the port B, and this LED is used as the output. So if pin B gives us a data, and if the data is masked correctly, or if it verifies, then the port C LED is high, it turns on. Else not, the port C will the LED won't turn on. So that's a simple code for it. And we go on to example 27, or I guess that was the 27, I guess. No, it was a 25. Let's move on to example number 27. Right. So it includes the library int main unsigned char bcd byte, unsigned char w, unsigned char z for ddrb as output. W is equal to w and 0x0f. W is equal to w less than 4. Z is equal to z and 0x0f. BCD byte is equal to W or Z. So it's W or Z. If any one of it is 1, it will be 1, or it will store the value of it. The port B is equal to BCD byte and return 0. It's a simple code, nothing much going on here. And let's move on to example number 30. So let's just quickly review these ones too. So we have the unsigned char my data and array we have initialized with the data set of in hex. Then the unsigned char chk sum is equal to 0 and char x. Then we have a port d as output. Then we have a for loop, and the x is going to run from 0 to 5, like 5 iterations: 0 1 2 3 4. And the chk sum is equal to chk sum plus my data. And the data my data is the array, and every array, the set that is the data that is going to run, it will get sum and stored in the chk sum. And if chk sum is equal to 0, like if the value of after sum is equal to 0, then the port d will show the value of g integer, or else the port d will show b. So it's a simple code to verify or check if my array is working, and if I send any data or a data list, so it will check it out for me. Then we have the example number 31. In the last example we'll overview in this video. As I include in main unsigned char x bin byte d1 d2 d3 ddrb is equal to ddrc is equal to ddrd. They are this p, c and d ports are initialized at output. Then the x is equal to bin byte divided by 10. So whatever the bin byte value is, it will get divided by 10, and the value is stored in x. Then the d1 d2 d3 similar operations are happening in. Then d port b is the d1 value stored in port b, the d2 is stored in port c and port d. So that's it for today. I think these are simple codes, and anyone having any trouble in it can comment, and I'll see if I can answer them, or maybe make another video about it. So I guess that's it for today. Thank you for watching. Goodbye.